Homework for sum number 1. It is given that y is equals to gx. The different values have been given. 1 for x is less than 0, 0 for x between 0 and 1, minus x for x between 1 and 2, and minus 2 for x greater than 2. Using these values we can plot the graph of y is equals to gx like this. For x less than 0, 1, 0 for x between 0 and 1, so till here we'll have nothing, and minus x for x between 1 and 2, so and minus 2 for x greater than 2. So this is the graph. Now for finding f of y, now for y in terms of for y between minus 2 and minus 1, first we find out y at minus 2. So probability of y at minus 2 is given by probability of x, probability when x is greater than 2, it is given by 1 minus fx of 2. Similarly we find it out at y is equals to 0. Now probability at y is equals to 0 is the same as probability when x is between 1 and 0, it is given by fx of 1 minus fx of 0. Now similarly we find it at y is equals to 1, it is given by probability when x is less than 0 is equals to fx 0. Now for between minus 2 and minus 1, we find small fy of y, which is given by f of x upon g dash of x, which is fx minus y capital minus 1 is equals to fx of minus y. Now f of y by y we have found out, and we can write it like this into delta of y plus 2 at y is equals to minus 2, and similarly we found out different values, we can write them like this. Minus 2 at y is equals to 0, it is given by fx 1 minus fx 0 into delta y, and fx of 0 delta y minus 1 at y is equals to 1. Now similarly we can find fy of y. First finding between minus 2 and minus 1, it is given by taking the integration from minus infinity to y, f of y alpha into d alpha. Simplifying it, we get plus fx of 2 plus minus alpha d alpha is equal to 1 minus fx of 2 plus minus y to 2 f of y minus alpha d alpha. Now further simplifying it, we get 1 minus capital Fx of 2 plus limit minus y to 2 fx into beta into db is equals to 1 minus fx of 2 plus limit minus infinity to 2 fx beta db minus infinity to minus y fx beta into d derivative of beta, which is given by 1 minus fx of 2 plus fx of 2 minus fx of minus y is equals to 1 minus fx of minus y. These two get cancelled out, so we can finally plot down f of y. It is given by 0 when y is less than minus 2, 1 minus fx of minus y between minus 2 and 1, 1 minus fx of 1 between minus 1 and 0, and 1 minus fx of 0 between 0 and 1. When y is greater than or equal to 1, the answer is 1. Now from small f of y and capital F of y, we can plot the graph in terms of fx and f of small f of x. This is the graph of capital F of x. This is the graph of small x fx to x. Now plotting fy of y. We already know the different values which we can take from here. These are the values of f of capital F of y, and using it we can plot the equation for values between minus 2 and minus 1, and then minus 1 to 0, 0 to 1, and for values greater than 1, the answer is this. So this is the graph of, this is for minus 2 to minus 1, minus 1 to 0, 0 to 1, and for values greater than 1. This is the graph of f of y. Now similarly plotting f of small f of y, taking the values which we have already found out between minus 2 and minus 1, it is given by this curve. At f of 0, it is given by 1. Area is equals to f of x of 1 minus f of x of 0, and at 1 it is given by fx0. Hence this is the solution for question number 1. Thank you.